maybe there's going to be a load that's placed on this that you found out later, or you knew about it, but you need a third part, if you will, to provide a little more support. So one thing I haven't done yet is draw from scratch, from the ground up in the context of an assembly. So you could just take those handy sketch tools in Spaceclaim and sketch out a brand new part right here in the context of the assembly. Any changes I want to make later on, that's not a problem to do. It's very simple, but I'm just sketching out what I think the general shape of this bracket's going to look like. Now this is great. I love this. Right when you go into the pull tool, Spaceclaim turns that sketch into a surface body. And you've already seen what I do with surface bodies. I start pulling on them, and I've got a solid. Now let's just throw that solid into a component, and we'll call it bracket. And maybe I want to work on this individually and do some optimization of it. Or I could work in the context of the assembly. It doesn't matter. Let's open it up, and there's going to be some optimization. Some things you want to change on this to, I don't know, maybe make it aesthetically pleasing, to drop the weight down, to just get your cost down in general. But again, I go back to somebody could be looking over your shoulder, and you could be making these changes as they're talking to you. You click on faces, you click on edges, you start making the changes in real time. So obviously there'll need to be some kind of a round right there. Maybe if you want to drop the weight down, you'd probably want to put a hole in the model, or a series of holes. So that's simple to do. I'll just draw out a circle and pull that straight through. But to drop the weight down even more, why have just a hole? I could actually put a slot in here. Making a change like that is very simple. I grab the axis, I pull on it, and I've got a slot. Maybe there's things you want to control. When you're running your analysis and you're going through iterations, you want to find out if this bracket is strong enough, and there's parameters you want to control, like the slot length. So what I could do, and it doesn't matter how I created the model, this is the important thing. I mean, for all I know, this could be an imported file. I can still go build intelligence into it at any time. So I've just said, let's call the width of that slot a parameter. And that's something that I could go quickly modify at any time. Remember that round I put in a second ago? Well, that's going to be important, more than likely. The dimension of that, I'll just call it radius. And if you remember, when I first made this, I didn't really give any concern to the thickness of this. I don't even know what it was. It was something around a ½ an inch, but let's say I want it to be a ½ an inch. And I want to vary the thickness. I want to see if that plays an important role. But I want the thickness to be defined from the center. I mean, this is a thin body part. So I can tell the system, go ahead and put an intelligent relationship in there, the thickness, and define it from the center. And I see it's about 540. So let's make a third parameter. Now the reason I'm making these is twofold. One, it gives you access to certain parameters you want to change down the road. It gives you quick access to them with just a button click. I could say this needs to be ½ an inch. That's a little bit thinner. But also, if you're using a tool like ANSYS, which we have an integration with, these tools get passed directly over to ANSYS. And so you could make your changes in Workbench. And we have integrations with other analysis tools as well. But that's just one I wanted to mention that I have right there. So then that means is you're running through iterations faster, and you've already programmed just the dimensions of concern to you into the model, not what someone that's a designer or a CAD jock did. You get to stay in control over this model and modify it and make changes and iterate it the way that you want to.